Hello RF Kit fans, this is Max NG7M and a follow-up video on my previous video about the clamps for the LDMOS devices on RF Kit RF2K plus, b26-RF2K plus. And I actually, based on the comments on the Groups.io group about the liquid metal, in particular thermal Grizzly liquid metal, TIM material, right? I've got a lot of experience with that. I'm kind of an enthusiast with high-end gaming PCs. So, for example, if you were to see my PC here, it's liquid cooled. I've delidded. It's an newer i7 delidded, and for years I've been using that liquid thermal material, particularly just on delidded CPUs between the cap, right, that you delid off the Intel CPU and then you put the liquid metal on between that and the silicon, and you get, wow, it makes a big difference on the cooling as far as computers go. But I don't know that I would recommend this. I'll let you guys be the judge. Based on the previous video, you have a good idea. You notice that I keyed the amp, turned the my Elecraft K3 down to 0 watts drive on 40 meters, and after about 5 minutes, if you watch the video, you can see the time span. It got up to, it touched on 49 degrees C. So I'm going to start that right here now. The same thing, it's 32 C right now, and then I'll show you some pictures. We'll talk about it and see, if there was a difference on using the thermal Grizzly. It's called conductinaut, and it's a liquid metal. I do have multi-year experience with it. It does not go hard, right? It stays in a state where you can clean it off if you were to pull the LDMOS devices. So let's see what happens. I'm going to go ahead and key the amplifier up here, and we're just like before. I just dropped the drive down to 0 watts as far as the K3S is concerned. So here you're going to see on screen right here, we're at 35 degrees C, and you're going to see that go up. And I'll talk a little bit about that after I leave it keyed. So here we're drawing 6.7 amps right when it's cold. Less amperage than before, if you remember in the other video. Outputs a little over 27 watts according to the good old LP 700 meter here. So here I'm going to try to keep this short. The conductinaut, there's pretty much two different kinds of from Thermal Grizzly, and they're really popular in the enthusiast PC world. You have the conductinaut. I've had this for probably 2 or 3 years, this package right here. And this is the liquid metal, for lack of a better term. And this is the cryonaut, which is highly rated. This is the non-conductive type of thermal paste that's used. And I'll use this between a heat sink and the heat spreader on a CPU, for example, because it's just overkill. It's like if you have a water block that's water cooling for a heat sink, I'll use that. So I am not using the cryonaut in this case on the RF Kit amplifier here, the b26-RF2K plus. What we're talking about here is this stuff, the conductinaut, and it comes with a little syringe to do, and it'll do multiple devices. I mean, I've done several CPUs. And so you have a little syringe here, and it's actually a liquid metal that beads up. Think of putting a ball of mercury in your hand, which is not a good idea because it absorbs in your bloodstream. That's what it looks like. It looks like mercury when you put it out, and then you spread it out onto your device with like a Q-tip, and that's exactly what I did. So anyway, conductinaut. And you can find that on Amazon or wherever. It's all over the internet. Really popular with the high-end gaming PC enthusiasts, the guys that are overclocking PCs, which I do too. I have fun with that. So, okay, back to the amplifier, up to 45 degrees C. Let me pull up some pictures I took of how I pulled the, oops, it popped up there. So I'll put a link to these in the post, of course, on Groups.io, and then in the link of the video here. So here you can see I pulled the PCB, the RF deck PCB, cleaned it up, and I just took a Dremel and I had a buffer, and I buffed the spots on the copper heat spreader for the main heatsink down here and left this in place. And by the way, just full disclosure, the thermal heat transfer material I'm using between the big the big copper heat spreader down here and the aluminum heatsink here, aluminum heatsink, I used a very liberal layer of the CW7100. I do not think you can go wrong with the CW7100, which Reinhardt, of course, has recommended over time for doing this. And I am not suggesting by any sense of the word that everybody needs to go out and change to this thermal Grizzly, liquid metal conductanaut stuff. This is just my experience. It's a kit. Hey, we like tinkering around. It's right before WPX, and I'll see how it plays out during the WPX. I am seeing better results. Not like, crazy better results, but it's definitely better. So the amplifier is still keyed. Here's a picture. I left the LDMOS devices obviously soldered in to the PCB. And man, the previous CW7100 was tough to clean off. You can kind of see that here, and there's another picture in here where you see that. I just didn't get that crazy cleaning it off because you could tell the silver material from the CW7100 was pretty much like adhered to the bottom of the LDMOS devices. In my case, it's the 189s. So we'll just look through the pictures here. This is where they're going to rest down on the copper heatsink spreader, and you can see kind of buffed that up. And this was overkill. This is where the input attenuator, the pad there. In my case, I have a 13 dB pad, as you saw in the previous video. And here's a close-up of when I clean things off. You can see I was trying to scrape off the CW7100. There's some coincidence there that it's CW7100, right? Continuous wave CW Morse code. But I was using denatured alcohol. I just wasn't going to get crazy and scrape every little teeny tiny bit of this off. Other guys might get a little more crazy with that, but I did not do that in this experiment here. So cleaned it off, cleaned off the whole bottom of the PCB for the heat spreader, and obviously this nice copper ground plane. And here you get a good shot of the liquid metal. This is the conductanaut. This is the infamous conductanaut, and it has the heat transfer is much higher than any of the paste type material. But in numbers, if you look at the rating on the ability of it to transfer heat, and I'm not going to get into that, the thermal transfer rating, it's like 77, and most of the other pastes are down in the teens, like 12 to 18, or maybe 22, somewhere around there. So the problem with this liquid metal is it's hard to spread out. And so as part of the kit, which I was just showing you, there are some Q-tips that are included that allow you to spread it out, and it spreads out pretty nice on copper like this, as you can see. So I just spread it out the size of the bottom of the LDMOS device, and you can see it's kind of, it's liquid. It's very liquid, like I mentioned before. It's kind of like a ball of mercury, as a bad example. And you could easily just wipe this off. It's very liquid-like, right? Like mercury. So let's go to the next video. Here you can see the LDMOS device. I put the PCB back down, and you can see where right here, if you can see my mouse, where that liquid material is kind of oozed out around under here. And then I've got some close-ups of this. So you can see what that looks like. I'm in the high-res mode here on the pictures. Move that over here a little bit. And I want to take at least 5 to 10 minutes here. So here is a close-up, right? You can see the conductanaut liquid metal kind of oozing out there. Right here, another shot. And another shot. And let's see. And another shot, and that's it. So let's go back here, and I don't even know how far I am into the video, but before, if we go back here, we're up to 48C, and this is the point I wanted to show. When I did the testing right after I put in the liquid metal, I left the rig key down just like this on 40 meters, 7 megahertz for over 10 minutes. It was like 10 or 11 minutes. I never did see it go above 48. Where before, if you look at my previous video and you look at the times on the video, I start the same test, and when I end it, it's about a 5-minute time frame when I'm talking through the pictures and going through what I did on the clamps, right, when I'm showing those pictures of the clamps. So just like this must have been it was yesterday evening when I did this. I sat here for over 10 minutes. I could not get it to go above 48C. So it is better, but it's, you know, I mean, it's not like, like some order of magnitude better. It's better. And time will tell as far as actually using this in a contest. So if I could see how long I'm into the video here, the timeline here, I wish I could see how many minutes I was in here. There's probably a way to do that. But anyway, let me do this. I'll do one test here at QRO. Now that you can see, as I've been rambling on here for however long the video is in at this point, it's just stuck right at 48C right here. And the output, let's go back to the meter. You know, as the amplifier heated up, it's drawing 6.4, 6.3, you know, bouncing around 6.4 amps. And the output dropped down to 23.6 watts according to this meter, how it's calibrated. And again, just pinned right to 48. And you might be able to hear the fans there. They're whatever the temperature is for 48C. And I do have the fans on the higher voltage, by the way. I made that clear in earlier videos. But you can see it's like just reached equilibrium there on 48C. So let's do if you want to go back to the previous video and do a comparison. I'm not going to take the time. I'm going to spend some time in the WPXCW, CQWPXCW that starts in about an hour and 19 minutes actually. We'll see how much or how motivated I am for that. So I'm going to unkey the exciter here, the K3S, and let's just drive it up to 1500 watts. We're at 48C. So I just unkeyed, give you an idea of how quickly it drops down here from 48 to 47. So there it's down to 47. It feels like it's cooling off quicker than it has before. Not in a huge way, but it cools off pretty quick with the liquid metal, that conductinaut. And it's conductive too. Oh, by the way, be careful when you put that on, right? You don't want to put so much on that it ends up somehow causing a problem with those LDMOS devices. My good friend Jim, W7CT, Whiskey 7 Charlie Tango, was just trying to call me there on Skype, so I'll call him back after we're done here. So again, I'm a talker here. We're down to 42C. I'm going to key it up again with 1 watt drive. We are generating at 42C. We've got about 185 watts out. We're just going to drive this right up to 1500 watts. I am at approximately 13 watts drive now, which is giving me 1300 plus watts out. And as soon as I get up to 17, 18, 19, 20 watts, we're 22 watts, just like the other video. We're right at 1500 watts out. And I'm actually in peak hold here. Let's make sure we just go to tune. So here it will just show you the exact current sampling of the frequency off the coupler there. So 24, 25 watts drive, maybe a little bit more. We're up to 51C. I'm just going to sit here until it gets up into the 60s. And let me come back over here and make me small on the video. Maybe. Okay, this is not scripted. Get this out of the way. Okay. Wow, I'm really messing things up here. There we go. Okay. Hey, another thing, if you don't like the length of my videos, too bad. You can jump forward, you can put it on high speed. I've had some really irritating comments on YouTube about my videos from these clowns that they don't do anything right. You know, you give them $20 and they complain because you didn't give them two $10 bills. It's unbelievable. Anyway, so it's up to 59 degrees C here, driving at you know, for the US legal limit out. And we'll let it go here. We're up to 60 C on 7 megahertz. I think it's better. I don't think it's heating up as fast as it did in my previous video. I'll let you guys judge on your own if you want to do this. You know, unless you're really into this like me and you have this stuff, I don't know if it's worth it, right? But you can see I've had a long key down time here at legal limit, and 62 degrees C, still going. Now if I go to 20 meters, obviously this is going to go up faster. So here I'm taking it higher this time around on 40 meters or 7 megahertz. I think I stopped keying the amp at 61 before, but I thought it might be interesting here to see you know, if it slows down as we get to the higher temperatures. And it appears that it is, right? I mean, I could drive it up a little bit more as it heats up. Just you know, now we're at 64. I applied you know, another watt of drive or something here to get more than 1500 watts. But anyway, it seems to be working well. The liquid metal made a difference. Whether you want to jump through the hoops to do that, or do a better job of lapping. I mean, you can get crazy, right? You could lap the top of the copper, the main heatsink. You could clean off the LDMOS devices that, you know, you could see I had a little bit of the old CW7100 on there. But 66 degrees C, the protection would kick in at 72 C here. That is a long key down time. You know, I think it's safe to say you can run this amplifier on, you know, 50-60% duty cycle on RTT, RTT, you know, radio teletype, and pretty decent turnaround time on CW. 20 meters, it's going to be hotter. Here I'll unkey it, and you know, if I go up to 20 meters, I'm on the dummy load still, so it's dropping down. It's at 66, 65. You can see it's coming down. I haven't keyed the amplifier obviously again. So we're down to 62, 61, 60, 59. It drops pretty quick. So I'm going to key it up. Now we are on 20 meters. That was 1 watt drive. I'm going to rapidly drive it up to 1500 watts on 14 megahertz here. There's 1600 watts drive into a dummy load. Okay, 22, 23 watts. Here we can look exactly. So we're at 21 watts, 22 watts there. So it's back up to 64 degrees centigrade, 65, which it was already heated up because of the time I spent on 7 megahertz. So you can see it's going up faster on 20 meters. 68, 69, and you know, that's enough for me. Anyway, there you go. Have fun. If you want to jump forward, backwards, you use the J as in Juliet key on your keyboard, K to pause, kilo to pause, L to jump ahead 10 seconds. If you want to go back 5 seconds and ahead 5 seconds, you use the arrow keys. 73 for now. Happy tinkering with the RF kit. I don't know that this is worth it, but I'm going to leave it in place because it seems to have helped a little bit. What the heck. 73 for now. Have fun, guys. Bye.